In this video, I'm going to go through some basic concepts of what a force is and how we calculate something called net force. And I'll also show you an important thing that we have in physics that we'll be using a lot in the upcoming chapters called a free body diagram. So to start off, a force we will define as just something, a push or a pull, that is capable of changing an object's state of motion. So something that can cause an object to change its motion. It doesn't mean it's going to change its motion, but it has the capability to do that. The units for force in physics are newtons, and that's symbolized by a capital N. So anytime you hear 5 newtons or 10 newtons, we're referring to a force. There's many different types of forces that we'll encounter. They can be kind of classified into two categories. One is contact forces, and the other is an at-a-distance force. A contact force is something that you would get if you pull on a rope, or you experience friction, or you push something. And there's other contact forces as well. But anytime two things are touching, you get a contact force. And then you have the at-a-distance forces. The one that we're most familiar with is gravity. There's also electricity and magnetism, and even the forces inside an atom, the nuclear forces, are at-a-distance forces. When we look at force, and we look at the forces that act on an object, one of the things that we want to do is draw what's called a free body diagram, also known as an FBD. A free body diagram is a diagram that shows all forces acting on an object. And it's a very simple drawing, but it's very useful. So just to show you a free body diagram, if I take a plane, see if I can draw a plane here, and I look at the forces that act on a plane when it's in flight. There's actually 4 forces that act on a plane when it's in flight. And to draw a free body diagram, we usually draw a dot right in the center of the object, and we draw the forces coming from that dot. So the 4 forces would be, the first one would be, there's gravity acting on the object, so I'm going to label this F, gravity. And force is a vector, so it needs an arrow, and the length of that arrow represents the size of the force. Now, to counter gravity, there's the plane's lift. So an arrow going up, I'm going to label that F, lift. So you have lift and gravity. And to move the plane forward, we have something called thrust. So F, thrust. And there's also air resistance that acts on a plane, and that acts in the opposite direction of the thrust. And I would label that F, and then the subscript would be, it's called drag. And those are 4 forces that act on a plane. You have the lift, gravity, thrust, and the drag. And this picture right here, with the dot in the middle, represents a free body diagram of the forces that act on a plane. And we can do this for all objects. And when you're dealing with objects that have multiple forces acting on them, what we usually do is we combine those forces to find something called the net force. So when there is more than one force acting on an object, we can combine the force vectors to find what we call the net force, or the sum of all forces. These are the same value. Sometimes people use the word net force, sometimes people use the word sum of forces. F net in an equation is written as F subscript net, and sum of the forces is written as sigma, sum of the forces, where a capital F is the variable force. When we sum all the forces, or we combine all the forces together, we can find 2 options. We can have forces that are balanced, or forces that are unbalanced. If I look at these forces here, and I'll say force number 1 to the left is 2 newtons, and force number 2 to the right is 2 newtons. And actually, because of the coordinate system, I'll make right positive and left negative. This is going to be, F1 is going to be a negative 2. What I would discover is that balanced force, the sum of the forces for these 2 objects, is 2 plus negative 2, or F1 plus F2, which is negative 2 plus 2, and that equals 0 newtons. And when forces are balanced, the sum of the forces, or the net force, equals 0. In an unbalanced scenario, let's say F1 is again negative 2 newtons, but now F2 is 6 newtons. If I just to use a different notation here, let's see, extend the page a little bit, F net, and I can replace that with sum of the forces equals F1 plus F2. I would get negative 2 plus 6, and I'm defining left to be negative. Right could be negative, but that's just my definition of positive and negative. F net equals 4 newtons, and whenever we have forces, a net force that does not equal 0, we call that an unbalanced force. So when we're looking at forces, what we need to do is realize that it's just a push or a pull, and that we can draw the forces coming from the center of the object, and we call this drawing a free body diagram. And then we can calculate the sum of the forces with a net force acting on the object. And if it turns out to be 0, we call that balanced, and if it comes out to be something other than 0, we call that unbalanced.